Choosing the right web sizing method is crucial, but how we measure the aneurysm is just as important. In fact, variations in measurement techniques may be the leading cause of inter-observer discrepancies. This highlights the need for a standardized approach to aneurysm measurement to ensure the selection of the largest safe device size while minimizing thromboembolic risks. For example, although many reports advocate the +2-2 sizing strategy in larger aneurysms, we do not routinely follow this practice. This is because we select the device based on the aneurysm's maximum dimensions, regardless of its morphology, which often means the selected device is already on the verge of oversizing by conventional standards. This allows us to reach the same results without significant width adjustment. The key feature of our strategy is that we focus only on the maximum diameter and height of intrasaccular space that can be filled with the web device. This is simple for cylindrical aneurysms thanks to their uniform shape that matches the web SL device perfectly. However, it will need adjustment for other complex morphologies, including non-cylindrical aneurysms, such as spherical or conical, where the web can still achieve full wall apposition, and irregular aneurysms with redundant spaces like daughter sacs that must be excluded from measurements. Regardless of the aneurysm's shape, the important key is to measure the maximum height and diameter of that area inside the aneurysm, where the web device can be physically squeezed into. This strategy ensures we always start with a device that either matches the aneurysm's volume or is slightly oversized, which eliminates the risk of device undersizing. Let's take a look at this spherical basilar tip aneurysm. On the bifurcation view, the widest measurement of the aneurysm measures 8.78 millimeters. Switching to the down the barrel view, we observe a maximum diameter of 7.77 millimeter. By averaging the two diameter measurements, we arrive at an average maximum diameter of 8.28 millimeter. The aneurysm also has a minimum height of 6.71 millimeter. This gives us the key dimensions we need for proper web device sizing. Based on these measurements and applying the +1-1 sizing rule, our ideal web dimensions would be 9.28 mm in width and 5.71 mm in height. The closest available device size matching these specifications is a 9 by 6 mm web SL. However, if we were to deploy a 9 by 6 mm web in this case, we'd encounter a sizing issue. While this device would fit a cylindrical aneurysm with the same maximum dimensions, our spherical aneurysm actually has a smaller overall volume. To avoid oversizing, we will need to downsize the device by reducing its height by 1 mm. This brings us to the ideal size for this aneurysm, a 9 by 5 mm web, which will provide optimal coverage and wall apposition. This was confirmed by a follow-up angiogram at 6 months, which showed complete occlusion of the treated aneurysm. Let us take a look at this basilar tip aneurysm. Notice how the operator has taken multiple measurements of its dimensions. This approach can potentially lead to confusing results. That's why we recommend sizing the web device using just the maximum height and width. Since we can all agree on the aneurysm's maximum dimensions, this approach not only simplifies sizing process, but also minimizes inter-observer variability. More importantly, by starting with a slightly larger device size then downsizing, we eliminate the risk of choosing a device that's too small for the aneurysm, which is the commonest cause of treatment failure. Although using an oversized device may initially seem daunting, it ultimately leads to better occlusion rates as the operator gains confidence in adjusting the device. While maximizing device size can be beneficial, it's important to recognize that an oversized implant is not always the optimal choice. In cases of challenging aneurysm anatomy, such as significant angulation or vasospasm secondary to acute SAH, selecting a smaller web device may be the wiser choice. This ensures smoother deployment and avoids potential complications.